Our next speaker is Dr. Markus Lenger. Markus is an American water futurist. He's CEO and co-founder of the Clean Blue Corporation, which is dedicated to inspiring an environmental revolution in wastewater management. Markus holds a doctorate in high-energy physics, and during his 30-year career in wastewater has developed, patented and marketed the Clean Blue Fog DS system, an at-source in-situ fog disposal system. Now, I'm guessing, Markus, you can tell me about that. I understand that to be fats, oils and grease. Is that correct? Okay. More recently, Markus has designed and developed water reuse control and building management systems, integrating IoT software and custom PC boards, all while establishing a full in-house production and manufacturing facility in Orange County in California. So he's been busy, and he's going to take some questions at the end of his presentation. Please welcome Markus Lenger to speak on wastewater management, inspiring an environmental revolution.
Thank you and good morning. So wastewater management, inspiring an environmental revolution. It's big words, but I do believe that's exactly what we need. We need to rethink how we're dealing with wastewater. Wastewater in itself, Pete, we've been working on some means in the United States to actually drop the word waste out of wastewater. There really is no such thing. We can't really waste water. There's water. It's a resource, period. So we have a global water crisis. I know that's been talked about, at length. I usually start out with that picture, and that picture, of course, is the famed Earth ride, Apollo 8. And this shows that all water is recycled. All water is reused. There's no water coming in, there's no water going out. This is the water we have, this is the water we gotta use. There's big problems. Sometimes we're fortunate, we don't see what's going on in the third world, the plight people have and kids have. And the biggest problem that I have of all of that is 1.5 million kids die from unsafe drinking water. That's, for me, absolutely unacceptable. And we all here in the room, we all have the expertise to change that, and we should. So I want to show a little bit like what we do with changing, what can be done in general, what are some ideas out there to do that. I want to go about two specific things that I want to talk about, because we don't have time to talk about all of the different things. One is DWATS, which stands for Decentralized Wastewater Treatment Systems, and the other one is water reuse. So if you look at, actually, this is the newest data that I could find from 2011, you can see that wastewater treatment is not something every country has. So there's a big potential to build that out. And if we want to reuse the water, and we want to reuse it from wastewater, then a wastewater treatment plant, although we have to kind of redefine how they work and what they do, is really the only way to get there. So, wastewater treatment, a consumer product. This is really an important piece to understand. Current technology and systems are just simply far too expensive. Most actually, at least in the United States, need a licensed operator. They need strict process control, and they need maintenance. And they're very over-engineered at times, cumbersome. And we're talking also old technology at times. If they require on-site operators or personnel, of course the cost goes up. And the cost is a problem. First world, we can all afford it. Third world, probably not. If we train them, then maybe they can do, but how do you make sure that they do what they're supposed to be doing? So a lot of that technology actually already exists. It just hasn't really been meaningfully implemented. And that's also a problem that we need to look at. We need to get clearinghouses for technologies. I'm talking a little bit later about exactly what needs to happen. A lot of the systems out there are completely proprietary, and they're really inadequate, and the systems really need to be open source. So we need to have a little bit of revolution, just what we have in software and in hardware. Open source means there's a blueprint that everybody gets to use. We kind of build around it. Examples for that would be Linux in computers, or Arduino in hardware, or a Raspberry Pi, if you're familiar with in the technology sector. There's a lot of open source. The standards are emerging, and we're working hard on that, but they do require expansions. So we do need to work more on standards, because we do want to make sure it's safe and people know what they're doing. So again, we need to design an affordable consumer product that treats water. And what I mean by that, about 30 years ago, if you wanted to produce and broadcast a video, you would look at about $500,000 to do that. Equipment, everything, broadcasting, leave alone, you can't broadcast it globally, just regionally. You carry that technology right now in your pocket, most likely. So this is kind of what really needs to happen with water treatment the same way. It needs to be something that we take the consumer out of it in the control. And again, I get a little bit later to what that means. It needs to be economical to run. And I see that a lot. Great ideas, and then the great standards, and we need to measure this, and we need to measure that, and we need to measure it that often. At the end of the day, it's just too expensive. And if it's too expensive, it won't be used, and then it's just an academic paper that gets lost somewhere. So it needs to be implementable. It needs to be remote managed and connected, IoT, Internet of Things. This is very important because we're not going to have the skill set to run this properly always on site. But it's very easy to have that remotely monitored. We can have people look at it every day. We can have people look at it every hour. In the United States, we work with disabled veterans that paralyzed, some of them, that can look at that data. So you give them something to do. Some of them are extremely educated. So you can make good things. It should be simple to install and operate. That's very important as well. It should have a low power consumption, so it can run off solar power or a different power source. Because sometimes if you need to treat water, you may not have any infrastructure, period, especially in third world countries. And it needs to be third world ready. That's what I mean by that. So let's look a little bit at what kind of water sources do we have in general. And so I'm just going real quick to definition. Rainwater harvesting is well established. Everybody should just do it. Even in Southern California, where we say, hey, it never rains. Well, you know, that means you should do it anyway, because every little bit helps. You know, you can't just say it's not enough for the effort. Plus, it's not that complicated to capture water off your roof. Oops. Gray water. Australia guys are doing a little bit better than the United States. We're kind of waking up to that, especially in California. In my opinion, the most underrated alternative water source. There's a lot of things that can be done with it, a lot more. Then on-site treatment. On-site wastewater technology for reuse, I say will be the norm in 10 to 15 years. It might actually be faster than that. I know that direct potable reuse is de facto legal already in the state of Arizona, the state of Oregon, Texas, and New Mexico. So they're doing it. The last thing is DWATs, and I get a little bit to that. That's decentralized wastewater treatment processing. It should replace, in my opinion, the traditional wastewater treatment plants. It's a lot cheaper, and it eliminates the costly sewers. And if you are a sewer district, you know how much money you're going to spend just maintaining and cleaning the sewer, making sure it doesn't leak and be in compliance. How about we drop the sewer? Why DWATs? Well, it's 2,000-year-old Roman technology. It kind of screams for a technology refresh, in my opinion. It's very expensive to build and maintain. It's very expensive to transport wastewater. Now, in the state of California, we spend a whooping 19%. That's almost 1/5 of our energy in the state of California is used to move water alone. That's massive. It's a very inefficient use of energy. And therefore, it has a very large carbon footprint. So we need to work on that. And in my opinion, it's a public health hazard. Sewers breed a lot of undesirable effects and rodents and so forth. So regulatory standards, we need new standards. The few standards that exist are actually quite inadequate. Specific standards are needed for the type of water reuse. That's one of the big things for me is it depends where the water comes from, and it depends what you want to use it for, and there should be a standard for that. We all agree that flushing your toilets and taking a shower, you don't need the same water quality, and that should be addressed. There's multiple competency standards needed to actually achieve that. It's not as easy as it sounds. You need to talk to all sorts of different experts and come together and get these standards. Also, one of the problems is that testing these systems. You can only test them that far in a lab, and then you have to kind of go out in the real world and you have to test them, and you need to find cities or districts that embrace that are ready to test it, that understand new stuff needs to be tested in a real-world environment. Otherwise, we don't know whether it performs or not. I've seen too many stuff that works great in a lab. They put it out in the field, fails miserably. That should be an international effort, because we all have different problems, and at the end of or different aspects of the problem. And at the end of the day, we want the same thing, and there's a lot to be learned from how other people or other countries treat certain problems. And I think we can all get to the table and compare notes. So I'm just going to go real quick through some technologies and applications that we are doing. Talked about the grease trap. So this is a grease trap, could be any wastewater enclosure. We designed these bioelements. They're very simple PVC plastic tubes that have biomedia in it. They have aerators in it. They have some electronics on top of it. They have no moving parts. And they turn any wastewater enclosure into a wastewater treatment plant. This is exactly the technology that we use for fats, oil, and greases. So we drop that into an existing grease interceptor. We also have done this, dropping it into lakes. We dropped it into riverbanks. We dropped it into all sorts of wastewater enclosures. This is just a very simple bioreactor, if you want so, aerobic treatment. Our fog DS system is basically we take it from the commercial kitchen. We treat it in the grease interceptors. You've seen in the graphic, this is kind of our bioelement. And the water with one more treatment step is actually good enough to be used for irrigation. Commercial kitchens, I don't know, in Australia and the United States, can use 75,000 to 150,000 liters a day. That's a lot of water if you recaptured it. So that's the kitchen water reuse. The DS technology itself, as we call it, is specifically designed to be used for commercial kitchen water. Commercial kitchens, as I've mentioned before, use large amounts of water. The problem contaminant is fats, oil, and grease. We are the leader in the commercial food sector doing that, and a discharge can be used. We have applications where it's treated for irrigation or for laundry. This is what the system looks like. This is actually for the airport in Miami, where we do for Gate Gourmet. It's a company that makes all the food that goes to airports. So this is actually treating the waste of a commercial kitchen with 160,000 square feet. Fuel harvesting, just want to go real quick into there. We also designed a system, very simple, where you can take actually the grease and turn it into biodiesel. Been successful with that as well. So we can take the waste out of a water and make it a usable product, in this case, biodiesel. All of this technology I just talked about is actually being put into the new Salt Lake City airport, and will be up and running next year. So it will be the first airport that completely reuses that water. We're very proud of that. So alternative water, a new resource. We have done a pilot system at the Purdue University where we reuse all the water. So we achieved actually net zero water. So we learned a couple of really interesting questions on that. DVODs, that's a typical DVOD system that we also built where we have these bioelements, quite a bit of them in it, to basically treat domestic waste, if you want so, sewage. There's also, besides that technology that I just talked about, there's other ways you can do that, innovative ways that I've seen around the globe being used that I think are kind of really neat. Vertical farming, of course, is growing it, but as you know, soil is a very good way of cleaning water. So these vertical farming systems are a great way to actually process water, especially the polishing if you need to do that. Here, vertical farming, this farm made a tremendous amount, 7,000 pounds of organic food per year on an acre, and that's an American acre. So if you wanted to aerate water, you can make this in a really nice feature. So it doesn't have to look like a wastewater treatment plant if you wanted to bring up the oxygen. It can look quite nice. Oops. This is another feature. This is actually a wastewater treatment plant right there, an aeration system. Same here. You can get art involved and make it sculptures. Those are aerators. So there's very unique and nice ways to do that, where also, as Pete pointed out, you can get people that usually are not interested in plumbing getting involved, because there can be a creative outlet. It's not always something very boring and something ugly and smelly. There's biofiltration. These walls, that's another way. And they actually clean the air and oxidize the pollution. So not only do they look good, they actually have a full function. So just to sum it up real quick, we actually took a stab on it, and we wanted to build a small controller that would control the water reuse in a private home, like a smart home, that would do all the aspects of it. So this is a product that we designed and we built in-house, even the boards in San Clemente, California. Proud of that as well. Conclusions, basically, so when designing a water system, you also always need to start with efficiency. That's going to be your first design goal, period. Water can be treated, again, to any desired quality. It's very important to understand what am I going to use the water for when I'm done treating it. The remote monitoring and control, even with artificial intelligence, ensures safe operation. This has been a really big thing with regulators. They said, like, how do you know this thing works the way it should? And say, look, it shuts down, it talks to you, it does all these things. It's monitoring. There's still a human that watches over it at the end of the day, but the systems will go offline and shut down if they no longer meet the safe parameters. As I said before, we need multidisciplinary standards. Even in the plumbing industry, you start looking at control systems. You need to start looking at how to measure water quality. There's going to be a lot more disciplines that will go into that field. A lot more knowledge that needs to be used. And the standards depending on water reuse. Now, those are, again, a real quick browse through it. Those are a few things we talked about. Are there any questions about it in particular?
None come through so far, Markus.
They've got to use this app, you see. And I'm looking, and there's nothing. Anyone, have I missed any? There's a couple come through. Newest first, oldest first, oldest first, newest first. Call it out, whoever it was.
All right.
Water crisis or population crisis?
It's demand versus availability.
Well, there's not much we can do about the population. I do think it's actually an engineering challenge. A lot of the problems that we have came from engineering looked at the wrong way sometimes, meant well, but implemented wrong. And I do think that in order to get out of that, it's an engineering challenge. We start to need to look at engineering a little bit different. So population, unless we get a real great space program going and start pollinating, I think we're kind of stuck. If we don't address it, I think nature will address it for us, quite frankly. Traditionally has, either a pandemic or war. So both of them, depending how evolved we want to be as human beings, should be absolutely unacceptable. So I think it's actually not a population. Yeah, we got some choices to make.
Choices to make.
Yeah. Thank you.
Very good. Thank you, Markus.
Thank you.